Welcome back to our video on the legendary mathematician Srinivasa Ramanujan and his groundbreaking discoveries. In the previous segment, we discussed some of Ramanujan's most famous contributions, including his new method for calculating pi, the Ramanujan prime, and the Ramanujan theta function. In this segment, we'll be discussing the remaining discoveries of Ramanujan. First up, we have Ramanujan's work on partitions of numbers. 5. Ramanujan's work on partitions of numbers. Partition of numbers is the study of the number of ways a positive integer can be expressed as a sum of positive integers. For example, the number 5 can be expressed as the sum of 1 plus 1 plus 1 plus 1 plus 1, 1 plus 1 plus 3, 2 plus 3, 1 plus 4, and 5. These are 5 different ways to express the number 5 as a sum of other numbers, so the number 5 is said to have 5 partitions. Ramanujan made significant contributions to the field of partition of numbers by coming up with a new way of counting the number of ways a positive integer can be expressed as a sum of other positive integers. He developed new methods for counting the number of partitions of a number, which provided new insights into the properties of the partitions of numbers. His work on partition of numbers has been influential in many areas of mathematics, including number theory, combinatorics, and representation theory. In simpler terms, Ramanujan studied the ways of breaking a number into smaller numbers and found a new way of counting the number of ways a positive integer can be expressed as a sum of other positive integers. His work in this area provided new insights into the properties of the partitions of numbers, and has been influential in many areas of mathematics. It's like trying to find different ways of arranging a pile of blocks to make a specific number. 6. Ramanujan-Hardy congruences. Ramanujan-Hardy congruences is a set of mathematical relations that were discovered by Ramanujan and Hardy. These congruences are between the partitions of numbers and modular forms, which are special types of complex functions that have many applications in modern mathematics and physics. Congruences are mathematical relations that involve the remainder when two numbers are divided by a third number. Ramanujan-Hardy congruences provided a way to relate the properties of partitions of numbers to the properties of modular forms, which is an important area of study in number theory. This discovery is considered an important step in understanding the properties of partitions of numbers and modular forms, and it has been influential in many areas of mathematics. In simpler terms, Ramanujan-Hardy congruences is a set of mathematical relations that show how the properties of partitions of numbers are related to the properties of modular forms. It's like discovering a set of hidden connections between two different areas of mathematics. 7. Ramanujan's contributions to modular forms and automorphic forms. Modular forms and automorphic forms are special types of complex functions that have many applications in modern mathematics and physics. They are used to study symmetry and patterns in various mathematical structures. Ramanujan made important contributions to the field of modular forms and automorphic forms. His work in this area has been influential in many areas of mathematics, including number theory and string theory. Ramanujan's work on modular forms and automorphic forms was particularly influential in the field of number theory. He discovered a large number of new modular forms, and he developed a new method for constructing these forms using a certain class of special functions called theta functions. He also made important contributions to the theory of modular forms of higher level, which are special types of modular forms that are associated with congruence subgroups of the modular group of higher level. His work on automorphic forms was also significant. He made important contributions to the theory of automorphic forms for the group GL2 of real 2x2 matrices, which is one of the most important areas of study in the theory of automorphic forms. Ramanujan's contributions to the theory of modular forms and automorphic forms have been important in understanding the properties of these functions and their applications. His work has been influential in many areas of mathematics, including number theory, representation theory, and string theory. Modular forms are complex functions that are defined on the upper half-plane of complex numbers, and they possess a certain kind of symmetry called modular invariance. Automorphic forms are a generalization of modular forms. They are defined on more general domains and they possess a similar kind of symmetry. Ramanujan's work on modular forms and automorphic forms provided new insights into the properties of these functions and their applications. In simpler terms, Ramanujan studied special types of mathematical functions called modular forms and automorphic forms, which help in understanding symmetry and patterns in various mathematical structures. His work in this area has been influential in many areas of mathematics, including number theory and string theory. It's like finding new ways to understand the patterns in a kaleidoscope. 8. Ramanujan's discovery of mock modular forms. Ramanujan discovered a class of special functions called mock modular forms, which have important applications in number theory and mathematical physics. These are mathematical functions that mimic the behavior of modular forms, but have slightly different properties. This discovery was important in understanding the properties of modular forms, and it has been influential in many areas of mathematics. A modular form is a special type of complex function defined on the upper half plane of complex numbers and that possess a certain kind of symmetry called modular invariance. A mock modular form, on the other hand, is a special type of complex function that mimic the behavior of modular forms, but it doesn't possess the same symmetry. Ramanujan's discovery of mock modular forms provided a new way of understanding the properties of modular forms and their applications in number theory and mathematical physics. Ramanujan's discovery of mock modular forms has led to the development of new methods for understanding the properties of modular forms, and it has been influential in many areas of mathematics, including number theory, representation theory, and string theory. In simpler terms, Ramanujan discovered a special type of mathematical functions called mock modular forms that mimic the behavior of modular forms but have slightly different properties. This discovery was important in understanding the properties of modular forms and has been influential in many areas of mathematics. It's like discovering a new species that looks similar to another but with different characteristics. In conclusion, Srinivasa Ramanujan was a legendary mathematician who made many groundbreaking discoveries in the field of mathematics. His contributions to mathematics have had a lasting impact and he is widely considered one of the greatest mathematicians of all time. His work in various areas of mathematics such as partition of numbers, modular forms, automorphic forms, mock modular forms, and congruences, have been influential in many areas of mathematics and physics. His work has led to the development of new methods for understanding the properties of mathematical structures and has opened up new areas of research. We hope this video has given you a better understanding of the life and work of this remarkable scientist. Thank you for watching.